So the next presentation is from a leading backsheet and encapsulation producer and supplier, Cybrid. Of course, today the topic is not the backsheet, but only the encapsulation. So Carl Wang, R&D Director of PV products at Cybrid, is going to talk about a breakthrough encapsulation solution to mitigate the UV absorption losses for heterojunction cells. And as from the title, you probably have a preface that, this was already talked by several others in the session today. Carl, the floor is yours.
Can you hear me? Yeah. I try to share my screen, but I think probably you can make it for me. Could you share my presentation? I can try to share my presentation, but
yeah, please try. If not, we can help.
Second. Yeah, now I think it should be okay. Yeah. Can you see my screen?
Yes.
Okay. Good. Hello, everybody. Yeah, I'm Carl from Cybrid. Yeah. Today, my topic is about RayBo film. Actually, RayBo is the brand name of our UV conversion film. Yeah, it could bring extra benefits to module mix. In this topic, I will introduce some background. Yeah, about the mechanism of the UV conversion film, and also I will introduce something about the conversion film technology. And at last, I will also propose some HDD solutions and some market players on HDD. Yeah. This is about it's about the function of the UV conversion film. We all know UV light is harmful to the polymer. It could cause carbon chain break, and it also could cause polymer degradation and some celluloid issues. So UV light is not very good to the polymer. For our UV conversion agent, it could transfer the UV light into the blue light. And currently we are also working to transfer the UV light to as visible light. It can bring extra benefits to the model mix. For our UV conversion agent, what we use is we are trying to blend it in the polymers. So it can be dispersed quite well in the polymer. This slide is about the mechanism of how our UV conversion agent works. UV conversion molecular, it can absorb the UV light and then it will become not stable. We call it excited state. Excited state is not stable and it has the intention to go back to a stable state. So during the period, the release, some heat will be released and also the blue light will be emitted. Currently, the UV agent we use is to emit the blue light. This is we call it Stokes shift. This slide is about the wavelengths. For our UV conversion agent, it could absorb the UV light roughly, for the majority of the wavelengths below 3.8, it could be absorbed and transferred to the blue light. Roughly is about 430 nanometer wavelengths. So it could have two functions. One is to absorb the UV light, and another is to emit the visible light, which will contribute a lot to the module output. So about the transition rate for our existing UV conversion agent, it performs quite well. It could almost transfer the UV light completely. The transition rate is above 96.5%. Yeah, currently for HJT modules, microcrystalline silicon dominates the market. So UV conversion agent is something a must for HJT because microcrystalline silicon is quite sensitive to UV light, and the silicon hydrogen bonds is very easy to break under the UV light, and the silicon hydrogen bond break, which will lead to the module output job. Yeah. Currently, with our existing UV conversion agent, the module output could increase about 1.5% to about 2%. Yeah, roughly, it's in this range. So if we give an example of 600 watt modules, the module output could increase about 10 to 15 watts. So I do believe some model maker could benefit a lot from the model output increase. Yeah. Yeah, so the data here I listed is from the top one HJT model mix. Yeah, we did a lot of lab work, and we compared the UV conversion agent performance with UV cutoff and also high transmittance encapsulant. And if we give an example as EVA encapsulant, we can say with our UV conversion agent, the EQE could increase about 5%. It's actually, I do believe it's a lot. The test, what we did is just we put the encapsulant and seal together. There's no glass on the top. If we have this glass on top, the EQE increase could be job. Yeah. And also we did some comparison in EPE based encapsulant. Yeah. And we also can find roughly it's about 13.2% increase if we use UV cutoff encapsulant as a benchmark. So we can see our UV conversion film performance very well, whatever in EVA-based material or EPE-based material. Yeah. Yeah, this is about the module output comparison. Yeah, the first is about the high transmittance film. You can see for the initial output, it looks quite good, but after the exposure outside for about 1 month, the output drop a lot. Yeah, so for high transmittance film, it's not stable. Yeah, also the initial output is quite good. And for UV cutoff film, so some module output will be much lower compared with the high transmittance film and also the UV conversion film. And the last is about the UV conversion film. It performance very, very good, whatever for in the initial stage and also after about 1 month exposure. Yeah. Roughly, we can see with our UV conversion film, so the module output, I mean the HJT modules, can increase about 1.5 to 2% compared with UV cutoff film. Normally, we will use UV cutoff film as a benchmark. Okay. Yeah, this is about the molecular structure of our UV conversion agent. Yeah, such a structure makes it very stable, and it was globally patented. Yeah, yeah, such a structure makes the product very stable. It could be performance quite well under the UV light, heat, and also moisture. Yeah. Yeah, regarding the history of the invention of the product, actually, the UV conversion agent was initially developed by Nitro Denko. Yeah, in 2013. Yeah. And Nitro Denko they started the business in 2014, but the market is quite limited, and they decided to sell the product to Chosu industry, in 2015. Currently, Chosu they licensed the product exclusively to Cybrid, and out of Japan. So for Cybrid, we have exclusively to use and to promote the product globally out of Japan. This is about the performance of the UV conversion agent. We can see the UV conversion agent performance very good after temperature heat, even after about 2,500 hours. The loss of the large conversion agent is very limited. It's roughly about less than 10%. So we can say our UV conversion agent is very stable. Even after the reliability test. We also did a lot of reliability tests. The first graph here is the field test. You can see you can easily observe it with our RayBo film. The output job is very limited. Roughly, it's below 1%. After put outside about 150 days, so it's much better than the normal product. We also did some other reliability tests, some like a UV and also damp heat test. With our UV conversion film, it performs much better than our competitors. So currently for this test, what we use is UV conversion EPE in the front side, and for the rear side, we use the high transmittance EPE. For the competitors, we use the same structure. So our UV conversion is better than our competitors. We based on the EPE encapsulant, we did a damp heat test. The first graph is front UV conversion EPE, and for the transparent EPE in the rear side, we can see some model output job is limited within the specification. And for the UV conversion EPE in both front and rear sides, it also performs quite good. So front graph, we can see the best. The best recommendation is like about we use UV conversion for both front and rear sides, but some customers probably say the cost could be a little bit higher. So another option is we could use UV conversion in the front side, and for the rear side we could use the high transmittance. That also performs quite well, and the model output job will below 5%, even after damp heat 3,000 hours. So next, what we did is based on EPE encapsulant, or is on EVA encapsulant. We did a damp heat test and also the UV test. So even for EVA-based modules, it could also perform quite well. So model output is limited. Normally, after damp heat test for about 2,000 hours, so model output job is about 3%. Normally less than 3%. Also, HJT module, I mean the UV conversion based HJT module is still quite new in China market, but for Japan, actually, it has already have a long history. For Nido Denko, they started a business about 10 years ago, and they accumulated a lot of experience. Currently, the UV conversion agent used in our RayBo film, actually, we have exactly the same molecular structure. And the process, what we use is also the same as chosen. Yeah. So we can see with our UV conversion film, actually it has a long history and it performs quite well. Yeah. Currently, our RayBo film has already been commercialized, and the total shipment will be above 5 gigawatts this year. Yeah. Yeah. This slide is about the estimation of the benefits with our RayBo film. Currently, yeah, we did some estimation, and roughly we can roughly about 57 million extra kWh will be generated with our UV conversion film. Yeah. So some HJT model makes they could benefit the higher performance of our UV conversion film. Yeah, also UV conversion film, it performs quite well, but it's not compatible with available materials. So currently we did a compatibility research with our UV conversion film. Currently, what we recommended is in the front side, we could use UV conversion film, and for the rear side, we could use a high transmission film. It could, yeah, with such a structure, it's quite compatible, and the performance will be quite good. And another option will be we use UV conversion film for both front sides and also the rear sides. Yeah, this is also what we recommended, and we we collect a lot of data based on such a structure. But we will not recommend the front side uses a UV conversion film, and for the rear side uses a UV cutoff film. For such a structure, we don't recommend. And another is our RayBo film is also could be compatible with beauty tape. Normally, we could use beauty tape as edge seal. Yeah, yes, that also work. Okay. Yeah, currently we are approaching the global HJT players in the market, and we are trying to promote our UV conversion film globally. Part of the HJT players, they have already been our customers, and currently we have a very close cooperation with them. And some HJT customers currently they are enjoying the benefits from our UV conversion film. Yeah. We hope more and more HJT modules could benefit from our UV conversion film. We are happy to work together with all the HJT players in the market. Yeah. This is what I would like to present. Yeah. Thank you, everybody.
Okay, thanks, Carl.
Yeah.
You know, it's really interesting presentation. You answered some of my questions already. But, you know, this light conversion film also hit by UV, right? So how is the stability of this film? So will it, because it's also taking some UV, so what is the stability of this film itself?
You mean
The light conversion film.
yeah, it means stability
of the film, the film which you are using, it is also hit by UV. So is it not degrading over time?
degradation. I mean,
Yeah.
yeah. Actually, yeah, our UV conversion film is quite stable. Yeah, currently we have already accumulated about 10 years outdoor experience, and yeah, based on our excision date, it could last roughly about 50 years. Yes, this is yes, this is based on our calculation.
Hmm.
Yeah.
And when you showed the mechanism, you also showed that it releases heat, right? So is this heat is going to impact the power output? So this is one of the question from Suresh Vemuri.
Actually, our conversion agent is quite stable. So the heat, it's quite stable even under the heat, moisture, and UV light. Yeah, it's it's quite stable. Yeah.
Uh, I think there are a few more questions in the chat window. Please stay back and answer these questions.
Mm.